Differential calculus, first principles.
Welcome to Become My Teacher. And of course, the lesson today is we are looking at the first lesson for derivating from first principles. So here we are derivating from first principles. There will be many questions which will be asked in terms of you differentiating or derivating. And whenever you are being asked, you may be asked to differentiate using derivative rules. You may be asked that something is maximum, you are still going to differentiate. You may be asked about an area or a maximum area, maximum surface area, maximum volume, you will differentiate. You may be asked about acceleration, you second differentiate. You may be asked about point of inflection, it's a second derivative as well. But there will be a specific question when you get into your calculus question that would be saying derivate the following using first principles, or rather differentiate the following using first principles. In terms of the formula for first principles, we all know it is f prime of x is equals to the limit of f of x plus h minus f of x all over h as h approaches 0. If you, of course, I'm going to put it on screen. I've just put it on screen for you right away. So firstly, in this particular instant, in example 1, it says determine the derivative of f of x is equals to x squared plus 1 from first principles. So our f, so this is example 1. Our f is x squared plus 1. We are differentiating this, or we are derivating this from first principles. Using first principles, the first thing you have to find when they say first principles, the first thing you're going to go for the fact that the f of x plus h. What did I do now? Wherever there was an x, now there is an x plus h. So now it's direct substitution. The original one, the original rule said to me f of x is equals to x squared plus 1. Now you see, now I'm looking for f of x plus h. So wherever there was an x, now there's going to be an x plus h, which f of x plus h. So wherever there was an x, I make sure that there's an x plus h. Are we together? Wherever there was an x, there's an x plus h, which would therefore, be equal to, which would therefore be equal to, wherever there was an x, what must there be? Must be an x plus h. X plus h all squared, because it was x squared. So wherever there was an x, now there's an x plus h. So x plus h squared now plus 1. That one must still be there. All I did is that, remember from first principle, the formula requires you to use f of x plus h, and it requires you to use f of x. Ladies and gentlemen, while that is so, you are now able to say, okay, fine, this is in grade 12. I know, please do that. I know that in grade 12, this is x squared plus 2xh plus h squared plus 1. Grade 12, are we together? I'm going to give you a little bit of some time. Can you please do that? If you feel like, it's too tough to get here, you just open the bracket twice, and then you use the FOIL method. Okay, you just open the bracket twice into x plus h into x plus h plus 1. Then you would do the FOIL method thereof, and that is your f of x plus h. Then you go to your formula of, ladies and gentlemen, of first principles. That is the f prime of x is equals to the limit as h approaches 0 of course, the formula is there, f of x plus h. Let's just do that. F of x plus h minus f of x all divided by h. Are we together? That would then become the following. That would then give us the following. That would say to us, what are we having? We're having f prime of x is equal. Remember, the limit must come after the equal sign. Do not make a mistake and going around and say f prime of x the limit h approaches 0 is equals to something like that. I've seen people doing those type of things in this world. There are many things that happen in this world, and you get surprised, and it happens also in a mathematical sense. The limit as h approaches 0. Now we are going for substitution. You are going to be paid for that substitution. So make sure that you substitute correctly. F of x minus, you know what? So f of x plus h is x squared plus 2xh plus that. So we substitute that all over h. Are we together? Let's substitute f of x plus h. It's going to be x squared plus 2xh, agreed, plus h squared plus 1, agreed, minus this minus x squared plus 1. I would always say to you, put the f of x in brackets, and I would say that because at times there might be a negative there, that negative would affect that. So always put the f of x in bracket just for safety and, well, for security, for safety and security. Let's go further. That is f prime of x is equal to, ladies and gentlemen, the limit as h approaches 0. Believe you me that x squared is going to subtract the x squared because that negative has an effect of that. So x squared minus x squared, that is 0, that goes away. Also the 1 is going to minus the 1, that goes away. So you are just going to be left with the 2xh plus h squared. Are we together? That's what you are left with. 2xh plus h squared. Which, if you want to go further, you can continue it here, where you will say, therefore, that will give the limit is equals to, f prime of x is equals to the limit as h approaches 0 of what? Of h into 2x plus h, are we together? All over h. All over h. What would then happen? F prime of x is equals to the limit as h approaches 0. Are we together? As h approaches 0. Well, look at the behavior there. Can you see that there the h, well, the h in the numerator would then cancel that h in the denominator. In that way, the h in the numerator gets rid of the h in the denominator. So you are actually having 2x plus h. 2x plus h, what would you do? The limit as h approaches 0. After this step where you have cancelled the h, after that step when you've cancelled the h, that's when you can actually substitute h to be 0 as h approaches 0. See what I mean? F prime of x is equals to, now the limit must disappear. When the limit disappears, 2x. Whenever the limit disappears, whenever I said 2x plus 0, the limit disappears. That step is very vital. Okay. And this would be a question of about 5 marks. There are some that are going for about 6 marks. So make sure that you get those marks. And f prime of x from first principles, of course, is equals to 2x. The issue of first principles is a very, very important issue, and it's something that one must actually make sure they understand very well. That is one example that I would love to get to do with you on first principles. Let me look at another example on first principles. Let's look at the other 2 examples, or rather 3 if needs be, Example 2 say, given the function of g of x is equal to minus x squared plus 3x minus 2, and it would say it determine g of x from first principles, and then b, it would say determine the gradient of the tangent to g at x minus 2, and c, it would say at which value of x is the gradient of the tangent equals to minus 3. And I've just put it on screen. First one, let us look at the graph. The graph, the function rather, f, it was given in terms of g of x is equals to minus x squared plus 3x minus 2. The first step is, of course, get the g of x plus h. Are we together? So whenever there was, or wherever, ladies and gentlemen, wherever there was an x, now there is an x plus h. Wherever there was an x, now there's an x plus h. So it's minus into x plus h squared, all squared, plus 3. Wherever there was an x, what do we have? We have an x plus h minus 2. Are we together? Minus 2. Now, that we know can be written in the form of minus. When we expand this is actually minus x squared minus 2xh minus h squared plus 3x plus 3h minus 2. Are we together? That is your g of x plus h. That is your g of x plus h, which will therefore d prime of x is equals to the limit as h approaches 0 of g of x plus h minus g of x all over h, which is the standard formula for dealing with this from first principles. Now, in this particular instance, what would then happen, we would have to make sure we substitute correctly. You get a mark for that correct substitution, grade 12. That is all over h. Be careful of that. Now I'm going to put the g of x plus h. Let's substitute that. It's going to be a minus x squared minus 2xh minus h squared plus 3x plus 3h minus 2 minus g of x. Minus, what is g of x? So I'm minusing, then I'm putting into brackets. It's going to be minus x, let's talk to me, minus x squared plus 3x minus 2 minus 2. Are we together? And in that particular instant, ladies and gentlemen, you are able to say, I'm therefore having a g, a g prime of x as the limit as h approaches 0, I put it to you that that negative when it multiplies in is going to be a negative, and a negative is a positive. An enemy of an enemy is a friend. Negative, and that 3 is going to be negative. A negative and a negative is a positive. So what am I going to have? I'm going to have a positive x squared. So minus x squared. The x squared goes away. The x squared goes away. And then I'm going to have a negative 3 and a positive 3. Then the 3x goes away. So 3x minus 3x is 0. And also a negative times negative is positive. So positive 2 minus 2 is 0. So what I'm going to be left with, ladies and gentlemen, I'm going to be left with instead minus 2xh minus h squared plus 3x. No. You can't be having that. You instead have plus 3h. That's what you are having now. And when we are having that, we are able to say the g prime of x as the limit, ladies and gentlemen, approaches 0 of, we are going to take out the common factor. Hello, talk to me. What's the common factor? The common factor, ladies and gentlemen, the common factor becomes h, beautiful, in the numerator, h into minus 2x minus h plus 3. And I put it to you that all over h, the h cancels the h, of course, which means we are left with g prime of x, the limit as h approaches 0 is equal to minus 2x minus h plus 3. Ladies and gentlemen, when we are here, of course, talk to me. Now we need to get rid of that, the limit. So the h is going to be 0. So g prime of x is equals to minus 2x minus 0 plus 3. So every time that issue of limit as h approaches 0 disappears, that h must be equals to 0. Therefore, the derivative of g with respect to x of that particular function becomes minus 2x plus 3 from first principles. Now, the question that would be then asked is the following. It says, determine the gradient of the tangent to g at x minus 2. Let us call this a, because it was a anyway. Now in b, we are determining the gradient of the tangent to g at x minus 2. When we determine the gradient of, the tangent, we are using the first derivative on the function. The gradient of the tangent is actually the first derivative. You would have done this when you started with this topic of differential calculus, when you are still dealing with average gradient, and the idea of a limit just before you arrived at first principles. You know that g prime of x is equals to, it's a minus 2x plus 3. We want the equation, or not the equation, but the gradient of the tangent when x is minus 2. The gradient of the tangent when x is minus 2. So the gradient of that tangent is actually g prime of x. We are looking for this when x is minus 2. So that gradient of that tangent is actually g prime when x is minus 2. That is the gradient of the tangent. That is the gradient of the tangent. And that would then become the following. Therefore, the gradient of that tangent is equal to minus 2 into minus 2 plus 3. That is 4, and that is 7. That's the gradient of that particular tangent at x minus 2. At which value of x is the gradient of the tangent equals to minus 3? I think this becomes a little bit of a nicer and a little bit simpler question in this particular whole question, or this. Remember, the gradient of the tangent is g prime of x is equals to minus 2x at any point on the graph. So it means here I'm going to have when g prime of x is equals to minus 3, meaning I'm having actually minus 3 is equals to minus 2x plus that, plus 3. Are we together? And that becomes, ladies and gentlemen, it becomes, taking that to that, it becomes a minus 6. Minus 6 is equals to a minus 2x, because you took the 3, you transpose the 3 to the other side, and you divide both sides by a negative 2. Dividing both sides by a negative 2, what happens, ladies and gentlemen? 3 is equals to x. So at that particular point in time, x is equals to 3. That's example number 2. Ladies and gentlemen, let us look into the last 2. Example 3. Well, it's actually the last example of determining from first principles. It's example 3, but it has A and B. Example 3 has A and B. Determine f prime of x from first principles if, let's say, A says, what it says, f of x is equals to x cubed. This is from first principles. So if it's from first principles, what do? It means we find ourselves having to find x, f of x plus h, because it's first principles. So is this visible? I'm not sure if it's visible enough. It looks nice. F of x plus h, f of x plus h is equals to into x plus h cubed. I'm going to change it. X cubed. So f of x plus h, because wherever there was an x, now there's an x plus h. Remember, the rule is still all cubed. Now, when you can open 3 brackets on this one, into x plus h, into x plus h, into x plus h. Then you can first deal with this bracket. These 2 first. You can first deal with these 2. Then you can work on that. And then you will realize you are actually going to have x cubed plus 3x squared h plus 3 xh squared plus h cubed. Therefore, if you have to go to first principles now, the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Are we together? F prime of x is equals to the limit as h approaches 0 all over h is x cubed plus 3x squared h. Ladies and gentlemen, we are substituting the f of x plus h. Are we together? We are substituting the f of x plus h. plus 3xh squared plus 3 plus h squared minus h cubed minus f of x. How to get minus f of x? That would then give the limit f prime of x is equals to the limit as h approaches 0 all over h x cubed minus x cubed, that gives a 0. Are we together? That gives a 0, so that we have 3x squared h plus 3x h squared plus h cubed, which will therefore be f prime of x. This implies that the limit as h approaches 0 all over h. You can take the common factor. What is the common factor? It's h. Are we together? H is 3x squared into 3x squared plus 3x plus h squared. Are we together? From here, we can be able to say this is going to be f prime of x is equals to the limit, ladies and gentlemen, as h approaches 0. Are we together? Of all over h is going to be h into 3x squared plus 3x. When you took out the h, it's still h plus h squared. Are we together? Then that will cancel that. Are we together? The h will get rid of the h. The h will get rid of the h. What would then happen? We will be left, I hope this is visible, the red, it is f prime of x, yes, is equals to the limit as h approaches 0, ladies and gentlemen. That is, we are dealing with this. I don't need that. From first principles, 3x squared plus 3xh plus h squared. Then I want to be able to remove that particular limit. Of course, I will say the f prime of x is equals to, as I remove the limit, I will just be left with 3x squared plus, ladies and gentlemen, 3x. I remove the limit as h approaches 0, so there must be a 0 there. Wherever there was an h, there must be a 0. And the derivative of f with respect to x, from first principles, is equals to 3x squared. 3x squared. But that's the a part of the question. Let us look at the final part, the b part of this question, determining or differentiating from first principles. Let us look at the last example of that, of differentiating from first principles. That is example 3b. That is example 3b, where we differentiate here, well, from first principles. Let us see. F of x is equals to 2 over x. B, f of x is equals to 2 over x. If f of x is equals to 2 over x, then we need f of x plus h. F of x plus h is equals to 2 over, wherever there was an x, what happens? Wherever there was an x, wherever there was an x, now there's an x plus. Wherever there was an x, now there's an x plus h. Are we together? Now you substitute into your formula. F prime of x is equals to is equals to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Are we together? That which would then be equal to f prime of x is equals to the limit as h approaches 0. Now I want us to look into what happens here in the numerator. The numerator, f of x plus h, is 2 of x plus h minus 2 of x, which is f of x. Can you see that? Can you see that? Which would then be able to give us the next step, or implies rather, that this is the limit as h approaches 0. I want to say something here that's very important. Remember, the whole numerator divides. You need to understand that very well. The whole numerator divides the whole denominator. That is important here. That is what we are. We have to remember and remind ourselves from primary school, that when the whole numerator all over the denominator, it actually divides, the numerator divides that particular denominator. So what we can do here, we can deal with the numerator by itself. The LCD of the numerator, is x into x plus h. Agreed? X and x plus h, that's the LCD. Okay? And you would remember x plus h into x plus h. How many times does the x plus h goes? It goes x times. Remember, guys, this is the difference between when you are solving. Here we are simplifying. So there's difference between equations and expressions, or rather when we simplify or solve. So into x plus h, how many times does it go there? It goes x times. That x multiplies that. We should have 2x minus this x. How many times does it go like? Okay. Remember, that's the LCD. Yeah? Let me make this clear to you. That's the LCD, x plus h. The x, how many times does it go into the LCD? How many times does the x go into the LCD? It goes x plus h. Are we together? Let me put it to you that way. It goes x plus h. So minus 2, these two, it multiplied by x plus h. You will see what I just said is that actually the denominator of that multiplies that, the denominator of that multiplies that. And of course, the LCD is kept. That would therefore become f prime of x is equals to the limit as h approaches 0 all over, ladies and gentlemen, that is 2x minus 2x. 2x minus 2x, ladies and gentlemen, that's 0. So that is minus 2h. Minus 2h. But there is something that we forgot. We said that is the denominator, and that is the numerator. Remember, we said that is the numerator. Don't make that mistake. Remember, this is all divided by h. Please don't forget that. Remember that whole numerator is divided by h. Don't forget that. And if it's divided by h, we can change that division into multiplication. That is 1 over h. Are we together? You remember that? That is 1 over h, meaning the h can cancel the h in the denominator, such that you are left with f prime of x is as the limit as h approaches 0. It's actually minus 2 over x into x plus h. Are we together? Because the h's cancel the h. Therefore, f prime of x, since we have cancelled the h, we can use the issue of the limit being 0 and then remove the word lim as h approaches 0. Minus 2 over x into x plus 0, ladies and gentlemen, therefore, the f prime of x is equals to minus 2 over x squared. And that is the derivative in terms of first principles of that particular function or that particular curve. Ladies and gentlemen, we'll see each other on the next lesson. That is the lesson on first principles. Keep on keeping on.